Welcome to Python Science. My name is Furkan. Today we are going to discuss numeric values in Python: integer, float, and complex. Previous tutorial was on text data type. We examined some of the features of the string type in Python. This is the second tutorial on data types. So let's start. We are using Jupyter Notebook for this tutorial series. If you do not have Jupyter Notebook, you can install Jupyter Notebook on the link that I shared on the right corner of this video. Also, you can have all of these codes for Jupyter Notebook and Visual Studio on my GitHub profile. My profile URL is in the description. You can go there and you can download these tutorial files from there. Let's start with numeric data types in Python. So we have three numeric types in the core. First one is integer. As you know, it's a whole number. And we have float. Also, we have complex number type. J is -1 square root, as you can remember from the math classes. So let's run this, and we just assign some values to those variables. Now we are going to see how to convert these data types into each other, like from integer to float, float to integer, or you can just round out the number, or if we have something like string with empty spaces or alphabetic characters inside it, what are we going to do with those numbers? So we are going to define all of these strings. All of these are string type, and we are going to convert these types into numeric types. So first, let's convert integer string to integer type. This is an integer string. It's a string with integer number. And if we want to convert this type into integer, we will use int with parentheses. Inside, we have the value. Let's run it. Type of the converted file's type is integer, and the integer value is 344, and also the string value is 344, but it's string type. This one is string type, this one is integer. So why are we converting this? Because when we are building our application, we need integer data type or numeric data type. Without the numeric data type, you cannot sum up. It will just add the number at the end of 344, and it will make, like, if you add 5 as a string, it will make 344 and 5. So for that reason, we have to convert the type of data into integer. Sometimes Python handles this by itself if it sees like both of them are integer, but it's not the risk that you want to take. So in this part, we are going to convert the float string, this string, to a floating point number. So let's try that. So we have the class type float with the value of 356.89, and we have the string value as it's shown. Float string to integer type. How are we going to convert some kind of number like this into an integer? It's a string with a floating point number, and we want to have integer type. So when we run it, it will throw some error. Invalid literal for integer with base 10. So it is not an integer. We know that, and we have to make the proper conversation first. So it's a float number that I can see. I will just put. So it's a floating point number. When I run this, it will give the integer part of the number. It's not rounding up or rounding down. It will just take the integer part of this number. Remember this, we are not rolling up or rolling down. It will always take the integer part of this number. If we have 0 here, it will take 0. So let's go another example. What it will do if we have some number with comma instead of point. Some of the languages, like in Turkish, they're using comma for floating point numbers. So what it says, could not convert the string to float because it cannot read this as a float. It will see this character and it will behave like it's an alphabetic character. So what do we need to do here? We have to make it replace comma with dot. So do we have the enough parentheses here? Yep. So let's copy this and put it here. And also let's put it here to see what will happen. We just replace the comma with dot in order to get the floating point number. Okay, you cannot use floating point numbers like this in Python. you have to use dot, not comma. So what do we have here? We have a number with the spaces. At the beginning, we have some spaces. At the end, I just put one, but you can put as many that you require. So what are we going to do? We are going to convert this empty number to floating point number. It's an integer, as you can see. When you are converting integer to float, it will work because it's also a floating point number with 0. What it does, it just converts the string to float with 128.0, and the string has some empty characters like spaces here. How come it handles this? Python is just stripping the string that you give and taking the value that you are giving as a number. It just strips this. So it's basically a Python behavior, Python 3 behavior. In Python 2, you will get an error for this, but in Python 3, it will just handles this by itself. So what else do we have? We have a mixed type of string variable with alphabetic and numeric characters inside it. Let's see what will happen if you run this. So it will throw an error because you cannot convert something like this into an integer or float. It won't work. If you try to convert it into integer, it won't work. So you can use regular expressions to just clear out or taking the number part of this string, but it will be on the intermediate section that we are going to use some regular expressions. If you wonder how are we going to do this, I will put a how-to video in my channel. You can go there and you can just watch that video. It will be a short video for regular expression to take numbers inside a string. You can go there and watch it. For now, just park it here. You cannot convert some kind of string with alphabetic and numeric characters mixed inside a string to integer or float or complex number. So let's go to the operations on numbers. When I run this, we assign 20 to A, we assign 5 to B. So we are making some operations. For summing up the numbers, we just use the basic mathematical operations. Here also subtracting, also dividing is the same, multiplying is the same, and also power of a number. When you use double multiply or asterisk, it will just take the power of that number. What else we have? If you want to take the root of a number, square root of 4, let's say, you can use like fractional numbers for taking this root. If you want to say like third of root, you can use just 3, 2, 4, whatever you want. So these are the basic operations on numbers. You can put spaces between the variables and the operators because PEP 8 also refers that you should use something like this in order to get some readable code. So what else we have here? We are going to define C as 2.7 as a floating point number, and we are going to do some operations with that. Also, we are going to use some integer with that. You can sum up some integer and floating point number. It will just handle the type by itself, the Python. Also subtracting, another option, also dividing, multiplying. You can do all of these operations and Python will handle the type by itself. This is another expression for taking the power of a number. So we are taking the A power C. What is it gonna do? It will be something like of 2.7. It will give this result and it's this. So as I mentioned above, when you are using integer with a floating point number, it will just take the whole part of that floating point number. It will just truncate the part with dot and the precision level. For converting types and the modulus operation, I just put some examples here. So we have A as 20 and C for 2.7. When we are casting these variables, if we say float A, it will just convert the integer number to float. And when we say integer, it will just take the whole part of that number, that floating point number. So for the modulus operation, if we use like 20 and 5, what will happen? So the modulus answer is like dividing 20 until it cannot be divided to be, let's say 5. So it's divisible by 5 4 times. It will be 0, the remaining. If we want the number of division operation for modulus, we use 2 slashes and it will give us 4. When you multiply b with 4, it will be 20 as a. Also, we have methods for that. If you do not want to use these, you can use one line with div mod a and b. It will give us the divider as 4, remaining as 0, like here. So it's a cool function. And most of the times we need modulus operator, like operating on tables and extracting data from web. We are using this modulus operations frequently. So what else we have? We have number n with minus 123. If we take the absolute value of n, it will give us the positive corresponding number of this n number. Absolute value is a mathematical function, and as you can remember from the math classes, it converts our negative numbers to positive, and positive numbers, it didn't do anything, it just gives the number. Okay, let's go formatting numbers. So we have like precisions for different floating numbers. So we want to have specific amount of number after the dot. What are we going to do? We're going to use format function for that. Format k is the floating point number. If we give dot 5g, what it will do, it will take 5 digits, including the whole number part. If we have something like this, it will take this much. It will just limit our print value with like 5 numbers. You cannot have more than 5 numbers, okay? So as the p, we have 0 at the beginning. If we have 0, it won't go there because 0 is not accepted as a number for that part. If you have 10, it will consider that as a number. But if you have 0, your number starts from here, because when you use something like this, it also shows us, okay? For that reason, it doesn't count 0 at the beginning if there is only one 0, 0 point something. Also, if we want to have something like 5 number after the dot, after the fraction, so we are using 5f for the fraction. So what it does, it just takes 5 numbers here. Formatting is very useful, and when it comes to just interpreting your results into an Excel file or in SQL database, you may want to format the numbers before putting the numbers in there. So when I make this 4, it will round up this number as 7, like here. It just formats and rounds the number. If we have 4 over there, it won't touch the 6. It will give dot 16. But when we have like 7, it will just round up the number, okay? It's formatting. If it's necessary, it's rounding up, okay? So in the complex part, I'm not going to go in details for the complex part because I have never used this part. If you wonder about that, I will just give some clues for the documentation. You can go there. You can just review the methods that they have in CMath library, complex math library. You can learn from there because I'm not going to go over this topic. I will just give the brief introduction for that. So what we have a complex number. In that number, we have imaginary part and the real part. Real part is this one. Imaginary part is this one with this. If it's minus, it will take the minus also. So let's print out. It takes this value and this value. It takes these values as floating point numbers, not integer. Even if it's an integer here, it will always return the floating point number. Our initial complex number is like this, and when we have like adding up some whole number, it will just add up that number into the real part. It won't add that number into the imaginary part. If we want to add up some complex part, imaginary part, we are using j. So when we use that, it will just add up the complex part. If we subtract, it will subtract from here. If we divide that number into some integer number, it will divide all of the constants, like real number and imaginary part. For now, I'm just skipping that into 2 basic core libraries, modules actually. Python call libraries as modules. So we have math module and CMath module. Math module is having the basic functions of mathematical operations. CMath has the complex number operations. I'm not going to go in details for CMath. I will just review math libraries methods. So let's go. We have some constants. Okay, I have to run this first. than this one because I have to import the module. So when I run this, it will give me the pi number. Math library has some constants, pi, e, as you know from the logarithmic functions, e number and tau number. It will be like 2 times pi and infinity. It's a cool function. When you are optimizing something, you need something infinite. Python has that for you. You do not just define a number like big number or big integer. You can just use infinity for that. So math none, when you have some variable and you want to compare it if it's a number or not a number, you can just condition for that, like if it's equal to none, then do something. If it's not equal to none, do something else. You can just throw error for that one. So here we have a floating point number, none value, and infinity for this one. I will just show the infinity. You have positive infinity and the negative infinity. Infinity is always on float. Actually, all of the constants are in here except this one, because this one is not a number. All of these are floating point numbers. So for the floating point numbers, we will need ceil and floor, rounding up and down. So ceil rounds up the number and floor rounds down the number. Let's run this. And as you can see, 3.4, it will 4 when we use ceil. If we use floor, it will just throw 3. If we use integer for taking the whole part of this number, it will just give us the 3. We can say that this and this will be same. Math module has some cool functions on probabilistic functions like factorial or permutation or combination. So we are going to review these functions. We have n and k value, 5 and 2. If we have like 5 factorial, it will be 120. If we have the permutation for that, 5 permutates 2, it will be 20. You can use this function to calculate it manually. If you do not give the k here in the permutation, it will just assume that as 1, and it will just calculate the permutation of that number. For the combination part, this function, as you can remember from your math or probability classes, we can use combination 5 and 2, it will be 10. Also, greatest common divisor is a function inside math module. When you use GCD, it will give you the greatest common divisor, greatest number that divides this and this. So 15 is the greatest number that divides both of these numbers. Taking a check if a number is finite or infinite, you can use these functions, is finite and is infinite. If it's finite, it will show you something like this. These numbers are finite, not going to the infinity. They are true. This is an infinity. If we just run, that it's infinite number. You can just use this for your conditions. If there is something with the infinity, you have to do something. If it's something with like finite number, you can do some mathematical operations on that number. But in the infinite number, you have to skip that number or assign something else. For this part, the numeric types is over. But if you want to learn more about these numeric types, go to the Python documentation. I just put some links here. So for the power and logarithmic functions, they are detailed here, given much more functions here. I'm not going to go in details for these part, like the beginner part of this tutorial series, but you can go there and just examine these functions and have idea about these things. In the advanced section, I'm just going to use logarithmic functions, trigonometric functions, angular conversations, and hyperbolic functions. There are some special functions. They're not so special, but I have never used them. I don't know. If you have like some weird project, like building up a module for Python and distributing that module to other people, I assume you cannot do that at this time. So in the further tutorials, I'm just going to give these informations, but not for now. Not go too fast. Just have the idea. say that there is a gamma function in the math library. Just know that. Make sure you subscribe my channel, and if you like this video, just put a like on this video, and if you have any question, put a comment and I will answer. Thank you for watching.